So in this video, I'm going to explain solution of Codeforces around 9.4 related for division 2. So in this video, I'm going to explain solution of two questions, problem number B and problem number C. So let's now start with problem number B. The name of problem B is collecting games. So what problem is said, I can perform an operation on the index, and how a operation is defined, I can choose that index, okay, and plus that in my sum. ठीक है. After after adding that number in my sum, I can choose any of the another number in that array such that that number is smaller than my sum. For example, initially if I've chosen the 20, then I can choose another number which is smaller than 20. For says I now choose uh, 5 index. Let's suppose this index. Then I will add this number in my sum, and my sum become 25. Then I can choose any other number which is smaller than or equal to 25. So what they have said, I have to tell them, if I choose the ith index, what is the maximum possible number of index I can choose further on. And by picking an index, I will remove that element from my array. Okay. So now let's go to this point. For example, in this case, my array is like 25, 1, 4, 2. 4 say if I pick up this number, okay, then my sum become equal to 4, right? Then what I can pick now? I can pick 2. Okay, I will pick 2. Then I will add pick in my number 2 in my number and remove this from my array. From also 2 also. Then it become now 7. Oh, it become now 6. Now I can choose 5 and 2 both of the numbers. 4 say I can choose 1 here. If I choose 1 here, then I will add it 1 here in my sum. Okay, now it become equal to 7. No, the number which is smaller than 7 is 5. So I can pick 5 also. Then I will again 5 add 5. Then it will become equal to 12. Right. So how a number I can choose? I can at most choose 3 numbers. If I choose, if I am choosing this index, I can at most choose 3 other indexes, because you see 12 is smaller than equal to 20, which means I cannot choose 20. Okay. So for the 4, my answer will be 3. For example, you can see for 4 index, my answer is 3. So how can I approach this problem? Okay. So this is pretty much great problem. I hope so. This problem is easier than problem number A. So you see, first of all, what I will do, I will simply sort the array. I will tell you the greedy method how you can approach this problem. First of all, you can simply sort the array. For example, if my array is like 25, 1, 4, 2. First of all, sort the array. Now after sorting, my array would become 1, 2, 4, 5, and 20. Okay. Then you say I will take a prefix sum of this array. I will tell you later why I am taking. Let's suppose take prefix sum. By taking prefix sum, my array would be like 1, 3, 7, 12, and 32. Okay. So now let's begin how you can approach this problem. So this is prefix sum here. Okay. For example, if I'm picking a number 5, right? I'm picking a number 5. So if I'm picking a number 5, which means I can always take which are numbers smaller than 5, regardless what are their values. I can always take the number which are smaller than or equal to 5, right? Which means if I'm taking this number, my ultimate prefix sum, my ultimate sum which I am storing at each index would be become 12. Yes, it is indeed. But you see, if I'm picking 5, my sum would become 5. Then I can choose 4 also, because 4 is smaller than 5. Okay, then 4. Then I can choose 2 also. There it is removing also by time also. So my now sum become equal to 9. 9 is greater than 2, which means I can add 2 also. Okay. Now my sum become equal to 11. My 11 is greater than or equal to 1 also. Then I can add 1 also here. You can see this is a number of operations. What is the sum of this? This is equal to 12 only. And what is 12? 12 is a prefix sum at this index only. Which means if I am picking the current number, the the minimum number of uh, sum which I can get is prefix sum at that position, right? Okay. So now what? How I can increase the sum? So you see, if I want to increase this sum, for example, if I'm choosing 5 here, so if I want to increase this number, what is the minimum possible value which I can add on further? For let me repeat again. If I'm choosing 5, okay, I have chosen the 5. What is the minimum sum which I can get by choosing 5 is 12. Okay, I can get a minimum sum of 12 by choosing 5 as a number. Okay, so what is now the next value? Greedily I can take so that my sum is greater than, my sum become larger, and that value should be minimum. So you see that value is equal to this value only. Which you see in this array, in this whole array, if my sum is this, what is the next possible value which I can took, so that my that value is minimum also. I'm talking about this, but this value should be minimum, which I should not next add in my number. Okay, let me tell you with another case. Let's suppose I'm picking 4 as a number. So if I'm picking 4 as a number, what is the minimum possible sum which I can get? The minimum possible sum which I will always get is 7. Okay, right. So what is the next value which I should add in my 7? Or I can say what is the next value in the, so these all numbers are erased. Okay, so what is the next value which I should add in my 7, so that my sum is greater than, which means the minimum possible value which I can add in 7 is 5 only, which is the next index. Okay, because you see my 7 is greater than 5, which means I cannot, because you can see I can conquer 5 here with using this sum. So by using this sum, what would be next sum become? My next sum will be this only, because it is 5. 7 plus 5 is equal to 12 only. But you see I cannot take under 20 with using 12, which means this operation is not valid. Okay, so this is our problem. How so? Because you see, I have to tell them whether I can conquer this part using this part, so that I can increase my subsequence. So what is the possible answer for the this index? The possible answer for the last index would be the number of occurrence only, because it is 4 only answer for this, right? Now next number, now next one. If I can conquer 12 using 20, or I can say if I can take on 20 using 12, which means the number of operation here would be 4 only. Which if at any point, for example, let's suppose it is 10 only, but this number operation 10 only, which means at 5 I can choose I can get a maximum sum of 12. Okay, by using a maximum sum of 12, I can choose another number 10, right? I can choose another number 10. So so eventually what are the number of states I can check? Is the number of states I can check is the number of states here only. Because no, if for example, if answer here is 4, then answer here would also be 4 only, because you see at the end I'm reaching at this index only, right? But suppose here 20 only, so now what, I cannot take on 12 using 20, so the answer would here only 3 only, because you see using 5 I can only take on these 3 position. Okay, but next I can take 5 using 7, right? So what would be the answer for 7 for this index? But answer for this index would be the answer on this index only, because you see my answer on this index is 3. So my answer for this index will also be 3, because you see if I'm taking 4 as index, I can easily take on 5. So if I can easily take on 5, the answer of 4 would also be the answer of 5 only. Okay, now what, can I take can I take on 3 using 4? No, I cannot take. So what would be answer? The answer would be 1 only, because you see, because you can see using uh, operation on this index, I can only take on 2 only, I can only take 1 only, and the answer for this index is only 0, because you see I cannot take 1 using 2. So what is my answer for 20? You see the 20 for answer is 20 is 4. For 5 for answer of 5 is 3. Answer of 1 is 0. Answer of 4 for answer of 4 my answer is 3. Okay, so this is the answer. For example, if I now let me repeat for another test case for the similar approach. So let's suppose maybe I will repeat it once more time only. So first of all, I will simply sort the array 1, 2, 4, 5, 20. Then what I will do, I will simply do the prefix sum 1, 3, 7, 12, and 32. Then I will check if I can take this index. If I take index, the minimum sum which I can get is 12 only. By using 12, what is the minimum possible value which I should add in my 12 is a element presenting in the next index only in the sorted manner. So what will the answer? Answer would be 3, 4, 3, 3, 1 and 0. So answer of 4 is, you can see answer of 4 is 3. So answer of 4 is 3. Answer of 8 is 2 is 1. Answer of 1 0. Answer of 5 3, and answer of 20 4. So 4 3 0 3 1. 4 3 0 3 1. So this is the problem intuition of problem number B. So now let's begin with explanation of problem number C. Okay. So what problem C asking us to do is simply I can take any two indexes in my array. That the index should not be equal. Okay. In my array, I can choose any of the two indexes, and what I can do, I can simply add the absolute difference of the both of the indexes in the end of the array. Right. So I can perform these operations k number of times, and they are provided as the k, and we have to tell them what is the minimum possible value I can get from my array by using these number of operation. And what is the operation? I can choose any two indexes from the array and add the absolute difference of both indexes to the end of the array. And the position which I have appended in the last of the array, I can also perform operation on that index also. For example, if my array is like, you can see here, 3, 9, 7, 15 and 1. Okay, so if I choose these two indexes and add, for example, the difference of these two is 6 only, so I will add 6 at the end of the array. So now in the another operation I can also take 6 comma 7, which is 1. Now in other operation I can also take 1 comma 1, which is 0, which means the minimum possible for k is equal to 3 0. So what problem is asking us to do, simply I can simply perform k number of operation which is given to us, and we have to tell them what is the minimum possible value in the array which I can get by performing this operation. Okay. So now let's I will give you some observation. So let's suppose you have k greater than equal to 2. So I will tell you the answer is same for all k greater than equal to 2. Why so? For example, if you have any two indexes, there is a very big array. For example, there is a very big array by A, B, C, D, E, F, G. Okay, there is a very big array, and there are some two numbers in the array. For example, I will tell you any two random elements like 17 comma 6. Okay, and it is h only, or whatever you can take. So for example, if my k is equal to 3 or greater than equal to 3, so let's suppose my k is equal to 3, so I will perform operation of this. Okay, so what is the absolute difference between them? The absolute difference between both of them is, mm, 11. Okay, yes, the difference between both of them is 11, right? So this is a I have perform one operation. In another option, what I can do, I can simply subtract a value from this. For example, 17 minus 6. What is 17 minus 6? For example, in single operation, what I do, I do a 17 minus 6, which I am getting 11. Okay. Now in the next operation, which I will do, I will simply subtract the larger value from the absolute difference. For example, in this case, my larger value is 17 and my absolute difference is 11. So I will simply subtract 17 minus 11. So what is its value? Its value is 6 only. Okay. I have performed another option. I am left with one more operation. So you see, my 6 and this 6 are not removed from my array because there is no condition of removing, because you see my 6 is also here, my another 6 is also here. For example, in this case, you see I'm adding 11, then now I'm taking a difference of 17 and 11 and appending 6 in the end of the array. Now you see, in the third operation I will simply choose a 6 comma 6, and you see the difference of 6 comma 6 is 0 only, which means if my k is greater than equal to 2, then my answer is always 0. Let me repeat it again. For example, if you have to add into numbers a comma b, and its absolute difference, for example, is something. For example, I have took number only. For example, I have two numbers like 7 comma 10, right? So what is absolute difference? Its absolute difference is 3. Okay, now what I will do, I will simply subtract the absolute difference from the maximum number. Okay, by subtracting the 10 minus 3 is 7 only. Now the third operation, I will simply subtract 7 comma 7 and my answer is 0. Okay, this is the case for k is greater than equal to 2, which means if my k is greater than or equal to 3, then my answer is always 0. Now what is the answer for the remaining part? K is equal to 1 and k is equal to 0, or k is equal to 2. Okay, so if we have k is equal to 1, if we have k is equal to 1, what is my answer? You see here, I can easily perform n square operation, right? I can easily perform n square option. So by using an n square operation, I will iterate a loop from I to n, and I will iterate from n to j to n, and I will calculate all the possible a of I minus a of j and their absolute difference, and find the minimum value among them and print the answer. But this is a case of k is equal to 1. But there is also one case remaining, which is k is equal to 2. So what could be my answer in this case? You see, if my k is greater than or equal to 3, then my answer is 0. K is equal to 1, then I can simply take a brute force approach, n square operation. But what is the case for n is equal to 2? This is the only pretty much thinking part of this question. What is my answer for k is equal to 2? Okay. So to finding k is equal to 2, you see, if for example I am taking this array only, I having operation like 2, 3, 7, 15, and 1. Okay. So if I am having k is equal to 2, what are the possible operation I can perform? So I can simply perform any operation. First of all, uh, tell me how I can get an absolute difference between two numbers. Okay. For example, if I'm taking a difference between 1 and 5, it is 14, which is not a minimum at all. So how can I minimize the absolute difference between number? By sorting the array, right? So first of all, I will sort the array for k is equal to 2. What my array would look like: 1, 3, 9, 7, 9, and 15. Okay. My new array would look like this. By sorting the array, I will always get the minimum absolute difference, right? So for the single operation, in a single operation, what I can do? I can simply take the absolute difference between two numbers. Okay, let's suppose I take a absolute difference between these two numbers. It is equal to 2. It is equal to 4. Here it is 2 again, and here it is 6 again. Okay, so in the single operation, I will get one of these values. I cannot get two of these values simultaneously, because you see, by performing operation on this array, or you can see on the absolute differences, by performing operation on the absolute differences, I should have need at least three operations. Because you see, in the single operation, I will find the, for example, let's suppose I'm performing operation on this index and this index. By performing operation on this index, I will at least need three indexes. Because you can see, a single operation for finding this, a single operation for finding this, and another operation for performing operation on these two. Which means in single operation, I will get one of the value among these array. Okay, right. So I will get one of the one. So I will get the one of this value from in a single operation. Now I am left with one more operation, right? So I will decrease this. So I will now left with one more operation. So to perform one more operation, how I can perform that operation? For example, let's suppose I'm dealing with here 2 only, right? So what is the nearest most position of 2 in this array? The nearest most position of 2 in this array is 3 and 1. Okay. So I will find the minimum among them. So absolute difference between 1 and 2 is 1, and absolute difference between 2 and 3 is also 1. Okay. So now let's consider another case. Let's suppose I am taking this 4. So what is the minimum difference among the number if I'm so what is the minimum possible absolute difference by if I'm taking 4 in this array? So if I'm taking 4, then I can place it with 3. So if I place it with 3, the answer is 1. If I place it with 1, my answer is 3. If I place it with 7, my answer is also 3. Let's suppose I'm taking the index number 2. Okay. By using index number 2, you can see I will also get the same result as this operation. Now let's see. I'm taking as a 6. So if I'm choosing 6 as a absolute difference, then what is in another option, from which number I should subtract 6 to get the minimum result? So I should subtract it from 7 either, or 9, or 3. I will not 3. I will use 7 or 9 only, because you see, these are the nearest most places in the 3, nearest most possible places from 6. So you see, by using performing operation on 6 and 7, my answer is 1. So minimum among them will be my final answer. So in this case, my answer would be 1 for k is equal to 2. Right, k is equal to 2, my answer is 1. So you see, here it is another case of 3 example. Here it is a case like 7, 4, 15, 12. So in this my k is equal to 3. So in this case my answer will always be 0. For example, I am taking these two indexes. The difference between them is 11, and the difference between 11 and 15 is again 4, and difference between 4 and 4 is again 0. So for k is equal to 3, my answer is 0. Right. Now this test case. Okay, this is an interesting test case. I will debug it for you for understanding more clearly the k is equal to 2 part. So let's suppose my array is like 42, 47, 50, and here it is 54, and again in 62 and 79. You see here the my array is already sorted. So in this case my k is equal to 2. Right. So in a single operation, what I can do, I can choose any of the absolute difference from among these. I cannot choose two operation. I cannot choose two absolute difference indeed, but I can only take one absolute difference. Now it's up to me which absolute difference I should take to minimize my answer. So absolute difference between these two is 5. Here it is 3. Here it is 4. And here it is 8. And here it is 8 plus 9. It is 17. Right. So let's suppose I'm taking 5 as an absolute difference. So what is the nearest most position in my array to get the answer? Wait a minute, here it is a little bit problem. I think so. Let's suppose, okay, right, got it. So you see, so what are my possible, so what are my possible outcomes? So among these, my minimum answer could be yes. Among these, my minimum answer could be, because you see, in single operation, I can get all these values. Okay, which means one among these values. In a single operation, I can get one among these values. Okay, so you see, my till now the minimum value is 3. Okay, in a zero operation, my minimum value is this. In a single operation, my minimum value is this. Okay, 3. But but if I take another option, if I take my last operation, what is my value? Okay, but you can see my all the numbers are smaller than 42. Okay, so which means I will never take the absolute difference of more than 42 in any of the case. So if I took 5, my answer would be, my one of the answer would be, you can say, 37. If I take 3, my answer can be 39. If I took, my answer can be 38 for the 4. If I take 8, my answer could be 34. If I take 17, similarly, my answer could be 25. Okay. But you see, but in this array, what is my minimum? My minimum is 25. But among all these values, my minimum is 3. So see, my answer is 3. So if I show this implementation, but you see, okay, if my k is greater than or equal to 2, greater than 2, then I will print 0 and return. After that, I will sort the array and check if my k is equal to 2, which means it is a case in which I will perform a single operation, and by by considering that single operation, I will find the minimum value. Okay, right. So if k is equal to 2, I will simply iterate and check the absolute difference between the any two values. Okay, but by choosing the absolute difference between any two values, I will simply find the nearest most possible element in my array using that difference. Okay, then I will find, then I will store the minimum of that difference in my answer. But you see here, if there is a case my lower bound gave me another number, then I will also consider the previous number in my candidate also. Then I will also consider that part also, my previous part in my array. If my case is equal to 1, I will simply brute force all the elements and put in the answer. So if I show the implementation of B question, you can see here, I haven't shown this also. So this is implementation of B question. First of all, what I'm taking the prefix sum. Okay. I'm first of all, and I'm assigning all the numbers with element number I. And in next part, what I'm doing, I'm simply checking if my prefix sum of I minus 1 is more than my array of I, then I will simply update my array of I minus 1 as array of current. And you see, I'm finding the all the index using a lower bound upper bound function and printing the answer for the B. So if you have any other doubts in these two questions, you can comment me down. And please don't forget to subscribe my channel. Till then, stay tuned for the next one. Thank you.